if we've got a situation where we don't know the exponent, then what we want to do is we just want to rewrite this in exponential form. Okay, so how would I rewrite this in exponential form? 2 to the x power equals 16. And I hope at this point you can recognize that this is actually just like last night's work. Okay, some of you will see the answer immediately and know what exponent it has to be. And others of you will want to change so that you have the same base. How could I change 16 so it has the same base? 2 to the 4th, right? So if you got to this point and you said 2 to the 4th equals 2 to the 4th, then of course if the bases are the same, then the exponents must be equal. So my answer would be x to the 4th, just like last night, right? So we look at the second one, same idea. Rewrite it in exponential form. What would it look like? 2 to the x power equals 1 over 128. And at this point, we've got to figure out how could I rewrite the 128 so that it has a power of 2. Okay, this is 2 to the negative 7. Very good, negative 7. So now that I know it's negative 7, you know if the bases are the same, then the exponents are equal, and x must equal negative 7. That's last night's work. Pretty straightforward, right? Okay. So here's a more typical situation if you don't know, if you have an unknown logarithm. You still want to write it in exponential form. So that's going to be 3 to the 4th equals x. That can't be any easier, can it? 3 to the 4th power is 81. So 81 equals x. Pretty straightforward, right? Now, obviously, we can make these more difficult, and Math 3 will make these more difficult. But this is the basics. This is how to get started with it, okay? This bottom one, log base 5 of x equals 6. Rewrite it. It's going to be 5 to the 6th power equals x. So I can just go to my calculator. Go to my calculator and get 15,625. Pretty straightforward? Okay. Not trying to trick anybody. Oh, wait. Yes, I am. So, how would I approach a problem like log base 4 of 2x plus 3? Okay, 4 to the 8th equals 2x plus 3. Yeah, well, before you do that, can you evaluate 4 to the 8th?
Yeah.
Okay, somebody help me out with that, please.
65,000.
Yeah, and it's really just a Math 1, Algebra 1 problem, right? Subtract 3. Subtract 3, and then 65, 5, 3, 3. And then divide by 2.
32,766.5.
One more time, 32,000.
32,766.5.
All right, and I believe you. Now we're in a situation where we don't know the base. So, yeah, I still think we're going to go... Writing it in exponential form worked in the last two situations. Let's try it again. So let's rewrite it in exponential form. That's x to the 3rd equals 1331. All right. And do you recognize now that this is not a new problem at all? How do you get x by itself? Take the 3rd root. So I'm going to do this problem two different ways. But I'm going to take the 3rd root of both sides. And how do you do that in your calculator?
Math.
Go back to your math button. Math. And there's a 3rd root. All right. So what's the 3rd root of 1331?
11.
It's 11. Okay. Now I mentioned that there is more than one way of doing this. I just want to remind you of something we studied last week. Okay. Last week, I could have said x to the 3rd equals 1331. How could I use a fractional exponent to undo the 3rd power? How about a 1/3? Very good. So if I raise both sides to the 1/3, what does raising something to the 1/3 mean? Doesn't it mean the 3rd root? So aren't these the same exact thing? Just a different way of writing it. Now look at this. What's 3 times a third? It's 1. It just goes. So it still undoes it, right? And you still end up with the same answer. Do me a favor and please put 1331 raised to the 1/3 power in your calculator and make sure we still get the same answer.
I got 11. Yep.
All right, good. I just want to make sure that you understand you can do it either direction. I want you to be very familiar with those fractional exponents.
Oh, now it does the one.
We got log, let's see, rewrite this as an exponent. It's going to be x to the 4th power is 81 over 256. I hope you don't use your calculator too much on this one. Oops. How are we going to get the x by itself?
4 3.
Well, be careful. It's not multiplying it by 1/4. It's raising it to the 1/4 power. So just be careful, okay?
Wait, is that the one you would rather do?
It doesn't matter.
You can't square it.
It doesn't really matter which way you go. At this point, guys, your calculator can handle this work, but honestly, I'd rather you pay attention to what's going on. It's asking you for the 4th root of 81. What number to the 4th power gives you 81? It's 3. What number? The 4th root of 256. What number to the 4th power gives you 256? 4. And if you can recognize that, without having to use your calculator, you're going to be in much better shape. Now, I do want you to go to your calculator math button now, though. Type in the logarithm base 3/4 of 81 over 256, and make sure you still get a 4. Okay. This one's a little trickier because I have an unknown base, and I actually have an x in my logarithm part right there in the middle of it. So this is going to be interesting, right? Rewrite it in exponential form. X to the 2nd. Very good. So how do I go about solving this? Oh, that's a good idea, but that doesn't work here. I know that you liked to think about the square root, but look what happens. That goes away, and I'm left with x equals square root 5x plus 6. Well, how do you solve square roots? You square them. But if you square them, you go right back to where you were.
This is a lose-lose situation.
Infinity.
So we don't want to go those directions.
You gotta solve the equation.
It is quadratic. Thank you for recognizing it. We have 4 different methods of solving quadratics. We could graph it.
No.
All right. But we know we want to make it equal to 0. Most of our methods make it equal to 0, right? Because I subtracted 5x from both sides, and I subtracted 6 from both sides. Yes, I could have, but then I would have had a negative x squared, and I don't like negative x squared. I'd rather have positive x squared. All right, it's your choice now. You can graph this. You can use the quadratic formula. You could complete the square, or factoring is the easiest for this situation. How does this factor?
X. Wait. 1, 3, and 2.
Minus 3.
Yeah.
And then
Minus 6 and a plus 1. And remember, the whole point of factoring is you set up 2 little equations, right? And over here, so x is negative 6. No, excuse me, positive 6.
Yeah, 6 and negative 1.
And x is negative 1. Now remember what I've been asking you to do. I want you to check your work. Is it unusual for us to get 2 different answers? All right, I would feel a little, that's the first time that's happened in a while, so I would feel a little anxious about having 2 answers. So let's check. I want you to use your calculator. I want you to plug in right up here log base 6, and then give me 5 times 6 plus 6, and check out to see if that works or not. You got log base 6, and then 5 times 6 plus 6. That's what you're trying off to the side. And does it equal 2? So good, I like that. So 6 is definitely an answer, isn't it? So 6 is an answer. Did you try negative 1?
Yeah, it's non-real.
All right. If you try negative 1 and you do log of base negative 1, parentheses, 5 times negative 1 plus 6, it says error, right? Non-real answer. Okay? And that's exactly what it is. It's got a negative base. Now, the other day, we didn't spend a whole lot of details and attention on our rules for logarithms as far as, remember it was always b had to be greater than this, and right? Well, look, in this case, my b is not greater than 0. Okay? And here's where I want you to really think. I'm going to erase this problem off to the side for some space. But I want you to think about what the graphs of this would look like. Okay? The graph of 5x plus 6, log base x of 5x plus 6, the graph of that would be, the graph of that would be my regular logarithm graph, right? Actually, it goes like this. And it would be shifted over to the left 5/6. Okay? So it would be right here. It would be shifted over, and it would go down at 5/6. Okay? Which means, what's the domain? X is got to be greater than 5/6. What number am I trying to plug in? I'm trying to plug in. I erased the wrong work. I'm sorry. I meant to erase over here. It was -1, right? -1 doesn't fit this, does it? So that's another reason it doesn't work. Oh, I'm so sorry I erased the wrong work. Oh well. All right. Now we're going to look at logarithms that might have the same base. Okay? Now, 2 days ago, when we had exponents with the same base, for example, 10 to the x and 10 to the 3x minus 4, oh my goodness, 3x minus 4, how did we handle that?
X equals 2.
Yeah, we knew if the bases were the same, then the exponents had to be the same. Well, guess what, guys? Is the base on a logarithm not the same as the base on an exponent?
Yeah.
So it's the same rule. So if these are the same, then these are equal. So that's pretty straightforward. Once I know that I have the same base on my logarithms, I can just write the equation x plus 1 equals 2x plus 10. Pretty simple, right? And then you can just solve this simple equation. See, if I subtract x and I subtract the 10, that's going to be -9 equals x. You can double check that work. Now what do I need you to do? Plug it in. I need you to plug it in and check. So I need you to check by going log base 5, and that's going to be -9 plus 1. Okay, so this was a non-real answer? Well, if this is not real, then of course it's not equal here, is it? Okay, so if it's not real, then what's my solution? That's right, this problem has no solution. Okay. Well, it's not always every negative. It just depends where the negative is. In this particular problem, if I were to look at this log of 5, if I were to look at that graph, it would be shifted to the left 1, right? So I would have this graph, it'd be shifted to the left 1. But what number am I trying to plug in? -9. -9 is clearly not in the domain, is it?
No.
Okay, so that's why it doesn't work.
But what does it have to equal?
Pardon me? Just want to remind you of the process here. Do these have the same base on this second problem?
Yes,
Yes, I do, because it's called.
Oh, thank you. You remember that it's called a common
10.
log. So these have a base of 10 even though it's not written down. So they do have a base of 10. So I can jump right to it and say 6x squared equals 1 minus 5x. And what type of problem is this? Okay, so my problem just switched from a logarithm problem to a quadratic problem. So now I have to use my quadratic techniques. I think we're going to add the 5x and subtract the 1 and get 6x squared plus 5x minus 1 equals 0. Bless you. This particular problem with a leading coefficient of 6, if you remember, those were generally the hardest to factor. So I don't think I want to factor it. With a leading coefficient, it also makes it hard to complete the square, plus this one's odd. So I think I'm going to stay away from completing the square. I could graph it, but I think that they're probably going to end up being irrational. So we're really kind of stuck here with the quadratic formula. So who's going to sing the quadratic formula?
That's a not me.
No.
Alright, what is it?
All right.
No, the last person with his finger on the nose has to do it.
All right. So the quadratic formula, as you guys recall, x equals negative b plus or minus the square root b squared minus 4ac divided by 2a. There you go. That's on film. That's on record. All right. Fill in the blanks. I've got negative b. That's going to be negative 5 plus or minus the square root of 5 squared minus 4 times 6 times negative 1. You see where all those numbers come from?
Oh, one idea.
2 times 6. Yes, it's been a while. Now, slow and steady wins the race here. I've got negative 5 plus or minus the square root of. That's 25 plus 24. Do you notice the sign change?
Yes.
Divided by 12. 25 plus 24 is 49. I like that. Do you like that it's the square root of 49?
Yes.
I do. Because that's a perfect square. That's negative 5 plus or minus 7 divided by 12. So I'm going to have two options, right? 1/6 and negative 1. What do I need to do with those? I'm going to have to check those. Okay? I must check these to make sure that they work. Because these two answers are solutions to this quadratic. But that does not mean that they are solutions to this logarithm. So I must check my work. So I need you to go all the way back up to the top. The original problem. And I want you to find the logarithm, base 10, of 6 times 1/6 squared. And I need you to check both of these to see which ones work and which ones don't.
Oh, 1/6 works.
What?
Okay. So we found out, of course, that in our calculator the 1/6 does work, but the negative 1 does not. So my final answer is just the 1/6.